Hey everyone, Jay here. Time for another Intro to Python lab. Today we're talking about arrays. Arrays in Python are a little bit different than most other languages. There is an add-on or an extension we can add to Python called NumPy or NumPy that adds a more classical type of array. For our purposes, we won't use that because installing it might be a little difficult for some beginners. And we can still play around in vanilla Python with some other things and get some good knowledge about arrays anyway. All right, so Python does have something called a list, another thing called a tuple, and another thing called a set. And here I have a little bit about the big takeaway difference between each one. So a list, which is the one I will be using, pretty much operates like an array. Not exactly, but it's pretty close. And at least for our introductory purposes, we won't know the difference today. We're going to put all our variables in here, and we'll talk about that, what that means. Okay, and we can add, we can change them, we can modify them, all that stuff. The difference is the tuple, you can't modify things. You can add and remove, but you can't change what's already there. And then the set is a little bit different as well. Sorry, the set is also unchangeable. You can add and remove, but this one is also not numerically indexed. And we'll see what that means in a future lab as well. So let's talk about, we're going to ignore the tuple in the set today, other than what I just said. And let's talk about the list, okay? So an array or a list is, you can kind of think about it as a row in a spreadsheet. It has all these containers for variables, and in some languages, they all have to be the same thing. So if it's integers, they all have to be integers. Or if it's a float or a decimal or a string, they all have to be the same. Some languages you can mix and match, some you can't. The more strict they are, though, let's say you're working in like a C++ and all the variables inside an array have to be the same exact data type. The benefit you get from being so strict is that is in speed of accessing that data type. Accessing any one of the array elements individually is the same speed. Doesn't matter where it is. Doesn't matter if it's 872 or if it's 5. It's the same because of the size of the data that's in there. The language knows, okay, it stores all of them in one spot in memory, and it's the index of each one is just a multiple of the memory size for that data type. And so if it's item number 872, the computer just says, okay, what's the memory size of one of those? We're going to multiply it by 872. We're going to index over that far. There it is. If it's number 9, it'll say, okay, what's the memory size? Multiply it by 9, and index over by 9, and there it is. Okay, so that's the amazing speed of an array. Some of more recently created languages allow you to have arrays that don't always have the same data type in them. They're much more convenient to work in, yes, but they don't have that speed because now they actually have to index by an uneven amount every time, right? Or maybe internally, they're not even storing on one large continuous bit of memory, chunk of memory, not a bit. And it may be all over the place. And then that slows things down compute-wise. However, you could argue that computers are pretty fast these days, so If the compute time is a little bit longer, it's okay, as long as the program runs well, is easy to understand and easy to maintain and cheaper to maintain. Those are all arguments that you could make one way or the other, right? So we're just going to use the list that's provided to us, right? We don't have a choice as to how fast it's going to be and how it's made at this point. So we're just going to use this list. I put a list in here that doesn't actually have all the digits 1 through 19. There's a couple missing, and we'll get to that. It's important to note that when we are indexing these, like I mentioned, like when the computer wants to find an index, the very first one is index 0. So the first one, you'll say, what's the memory size multiplied by 0? The first one is in the 0 slot, right? So remember, index arrays start at 0 when we get to indexing them. So I've created this list type array, and we use the square bracket around it and then a comma to separate each individual element that's in there. You may hear me call these things an individual item in a list. You may hear me call them an individual item, a element, an index, a subscript, a sub. Okay, all of those things. There's just me saying the same thing in a different way. And if you hear it from elsewhere, probably the same thing as well, right? So don't think I'm talking about two different things. I'm kind of always talking about the same thing. I'm talking about one individual item in an array. So they're all separated by a comma when we define it. There are a few ways to define arrays. Putting all the initial information in there is one way. You could also create an empty array and then add things to it, maybe even in a loop. Okay, that would be great. That'd save a lot of writing, right? But this time I have this array here that I've created. It's missing a few things. We're going to fix it. Okay, so scroll down and I just have a welcome message. I'm going to print my list. Okay, and the way we print my list, if you wanted to print this way, Python does a really cool thing where you just do print. You put the name of the variable in there and it will print, right? It's not going to print in the most human readable way. So if you want it to print in some special way, you have to make a function that prints exactly the way you want it to. But for now, I'm just going to print the list so we can see what it looks like unaltered. Then I'm going to add the numbers that are missing in order to count all the way up to 25. So far I counted up to 19. I missed a couple, and then I want it to count all the way to 25. So I need to append at the end of the list the missing numbers. Now I can't necessarily append all of them at once. It doesn't let me to do it, not this way anyway. So I'm going to append each one at a time. Not very hard, there's only 6. Then I'm going to print the list again so I can see what it looks like again, and I can show the user what it looks like. And then I'm going to add the missing ones. So I'm missing digits 6, 11, and 17, and I can insert them into the index where they belong. So I need to make sure that I insert them in the right order, otherwise the indexes won't be what I think they are when I'm adding it or inserting it. So number 6 should be at index 5 in its rightful place. Starting at 0, which is the number 1, and then index 1 is number 2, index 2 is number 3, index 3 is number 4, index 4 is number 5, and index 5 is number 6. Right? So that's where we'll insert it. And the way this works in Python, you will insert and it will push everything to the side and it will squeeze that number right in where it belongs. Okay. We don't necessarily have to worry about how all that works internally. Let Python handle itself. Okay. Much later on, you can worry about exactly how it does it. and whether it's efficient, we're just going to get it done. Right, then I'm going to add the digit 11 in the 10 index. I'm going to add the digit 17 in the 16 index. And those are all the missing digits, I think. And then I'm going to print the list again, print a goodbye message, and that's it. And don't forget, I always have my if name equals main to call my main section of my program here. And I always have my comments and my shebang at the top. Right, so let's run this. Let's put this up here a little bit and go ahead and run. And we see the outputs that we have our welcome message. We have printing the list unedited, okay, and it even has exactly what the list will look like. So I could just take this and copy and paste it and create a new list in some other code somewhere. It has the square brackets and the commas and everything. Okay. Then I appended my numbers from 20 to 25 right here. I printed it, and here we go. That's what it looks like. And then I inserted and fixed. I put the number 6 in the 5 index. 0, 1, 2, 3, 4, 5 index. 6, 7, 8, 9. The 10 index is where I inserted the 11. 11, 12, 13, 14, 15, and the 16 index is where I inserted the 17 digit. And now it counts from 1 to 25. Okay, that's it. That is it for this lab. Okay, give you a moment to see all the content that I have in here. All right, that's it. Got another lab coming for you. And as always, thanks for watching, and I'll see you next time.